Hey everyone, and welcome. Today, we're going to unpack one of the most powerful tools in statistics, hypothesis testing. Now, I know it sounds a little intimidating, but trust me, by the end of this, you're going to see exactly how it helps you make way smarter, data-backed decisions. So, let's dive in.
So let me ask you this. You're at a crossroads. You have to make a huge, expensive decision that could impact your entire company. The catch? You can't pull every single customer or run an experiment forever. You've only got a tiny little slice of data. So how do you bet the farm on that small slice? Well, that is the exact problem that hypothesis testing was built to solve.
And look, we are not going to get lost in a jungle of complicated formulas today, not at all. I want you to think of this as the Tao Salon of statistics. We're here to find that intuitive wisdom, that elegant, powerful structure that lives behind all the numbers. The best way to do that? Let's just learn by doing.
Okay, so for our first case study, I want you to imagine you're the manager of a big department store. You're thinking about rolling out a brand new and, yeah, probably pretty expensive billing system for all your credit customers. And you need to know, is this thing actually going to be worth the investment?
So, here's the deal. The new system only makes financial sense if the average customer account is more than $70. Simple enough. So the manager pulls a random sample of 200 accounts, and guess what? The average comes out to $74. So we're done here, right? 74 is bigger than 70. Well, not so fast. How can we be sure that $4 difference is a real thing and not just some random fluke in our sample? That right there is the million-dollar question.
Now, this next bit is maybe the most crucial step in the whole process. We have to set up two competing ideas. First up is the null hypothesis, or H-naught. Just think of this as the status quo, the default assumption, the world where nothing interesting is happening. In this case, it's that the average account is exactly $70. Then you've got the alternate hypothesis, H1. This is what our manager is hoping to find evidence for, that the average is actually greater than $70. And here's a pro tip that's going to save you a ton of headaches. Whatever you are trying to prove, put that in your alternate hypothesis.
We're just going to follow this nice, clean, 5-step framework to get our answer. We've already done step 1, which is the hardest part. Now let's see what the data has to say by calculating something called a test statistic.
Okay, so after we run the numbers through the formula, we get this, a z-score of 1.886. I want you to think of this number as a kind of surprisometer. It tells us just how surprising our result of $74 is if the real average was actually 70. It's basically measuring the gap between our sample and the status quo, and it accounts for all the natural randomness in the data. The bigger the z-score, the more surprised we should be. So, is 1.886 surprising enough to make us doubt that original $70 assumption?
To figure that out, we have two really common methods we can use. Think of them like two different lenses for looking at that z-score. They ask slightly different questions, they look a little different on paper, but, and this is key, they will always lead you to the exact same conclusion.
Okay, let's break this down. The first method, the rejection region, is kind of like setting a high jump bar. Before we even start, we decide that if our result is in the top, say 5% of the most extreme outcomes, we'll call it significant. For this test, that bar is at a z-score of 1.645. Well, our z-score is 1.886, so we cleared the bar. The p-value method asks a different question. What's the probability of getting a result this extreme or even more extreme just by random chance? Turns out it's only about 3%. And since 3% is less than our 5% cutoff for what we consider rare, we also call this a significant result. See? Same conclusion.
So both paths lead us right here. We reject the null hypothesis. There is enough statistical evidence to say, with confidence, that the mean monthly account is actually greater than $70. For our manager, that's the green light. The data says the new system is very likely to be a good investment.
All right, let's switch gears and level up a little bit with a second case study. This one is about a brand new toll road. The whole project was financed based on an engineering firm's forecast that, on average, 8,500 cars would use it every single day. But this time, there's a twist.
And this quote just nails the problem perfectly. Think about it. If they overestimate the traffic, well, they're not going to make their money back. That's bad. But if they underestimate the traffic, they've built a road that's too small, leading to gridlock and angry drivers. That's also bad. Being wrong in either direction is a costly mistake.
This situation calls for a totally different setup. Our null hypothesis, our status quo, is still that the original estimate is right on the money, 8,500 cars. But now, look at our alternate hypothesis. We're just saying the daily average is not 8,500. We don't care if it's more or less, we just want to know if the original number is wrong. This is what we call a two-tailed test.
So, after the first 30 days, they collected data. The average is actually 8,120 cars, which gives us a z-score of negative 2.191. Now that seems pretty far from zero, doesn't it? But here's the catch with a two-tailed test. That 5% rare zone we talked about, we have to split it in half. We put 2.5% in the high end and 2.5% in the low end. This actually makes the bar for significance much higher to clear on either side.
And so, here is the verdict. Even with that seemingly large z-score, we do not reject the null hypothesis. The evidence, in this case, just wasn't strong enough to say that the original forecast of 8,500 cars was wrong. And this leads us to what is, without a doubt, the single most important rule in all of hypothesis testing.
Please burn this into your brain. Notice the careful wording here. We failed to reject the null. We did not accept the null. And this isn't just a nerdy little semantic game. It's everything. Think of it like a courtroom. A not guilty verdict doesn't mean the person is proven innocent. It just means the prosecution didn't have enough evidence for a conviction. Same thing here. Failing to find evidence against the status quo isn't the same as proving the status quo is true.
Okay, so we've walked through the mechanics, we've seen a clear yes, and we've seen a more murky, inconclusive result. So now let's zoom out and boil all of this down into 3 really powerful insights that you can take and apply directly to your work in business, marketing, or really anywhere.
Insight number 1, the setup is everything. Seriously, the care and precision you use to frame your null and alternate hypotheses, that defines your entire experiment. It forces you to get crystal clear on what you're actually trying to find evidence for before you even peek at the data.
So in marketing, when you're running an A/B test, your alternate hypothesis shouldn't just be the ads are different. No, it should be my new ad is better. You're specifically looking for proof of improvement. And for consumer research, you're not just looking for any change. You need to test if a new feature provides a statistically significant improvement, something more than just random noise.
Number 2, think of hypothesis testing as your best defense against wishful thinking. The burden of proof is high and it's on your new idea. It doesn't prove your idea is right. It just provides enough evidence to say that an old assumption, the status quo, is likely wrong. Your new idea has to be so compelling that the data literally shouts down the old way of thinking.
This whole framework is an amazing antidote to confirmation bias. It forces you to challenge the status quo with hard evidence, not just defend your pet project with a hunch. As a product manager, you have to actively reject the hypothesis of customers don't care before you can start claiming they love your new feature.
And finally, insight number 3. This is probably the most misunderstood part, but it's also the most valuable. When a test comes back inconclusive, like our toll road example, it is not a failure. It does not prove the null hypothesis. All it means is that with the data you had in this one specific test, you didn't have enough statistical power to make a strong conclusion. That's it.
This is absolutely critical for anyone involved in innovation. An inconclusive result doesn't mean you should kill the new idea. It might just be a sign that you need a bigger sample, or maybe a more clever experiment. It protects you from making the huge mistake of killing a potentially great idea just because your first test was a little too small or a little too noisy.
So I'm going to leave you with this one question to chew on. In your work, in your company, in your industry, what's a long-held assumption? A we've always done it this way kind of belief? What's a status quo that's just sitting there waiting for you to challenge it with data? Thanks for joining me.